Yeah, maybe you could just sort of tell us a bit about what you're working on at the moment.
Okay. Yeah. So sorry. I should get my introduction of myself first. My name is Zhijie. I'm a postdoc working at TU Delft, working on blockchain technology in general, and more specifically, the major research topic is consensus algorithm. And yeah, so this kind of core theoretical stuff of blockchain, and quite a big part in scalability of blockchain. Yeah, and well, besides the theoretical study that I'm doing on consensus algorithm, I'm also involved in the privacy and also the applicational part of blockchain.
Okay, so
yeah.
With things like, as you mentioned in your email, you were talking about the problems with the definition of scalability.
Yeah.
How big an impact does that have, and is that damaging when like various people are using different definitions? Does it apply to things like privacy as well? Are people viewing privacy in different ways?
Yeah. So that's kind of annoying, especially for the newcomers to come into this area. For us, it's fine because we know exactly what our people are talking about when they say, for example, scalable. But for newcomers, especially for some researchers who do not know exactly what's the scalability and blockchain, this core theoretical part of blockchain, it is very confusing. I read many reports who actually mess up like scalable with scale out, and also like mess up the scalability problem of proof of work of Bitcoin, and they mess it up with the BFT scalability problem.
Okay.
So yeah, so it's kind of a tough situation. For example, some I will not name the project. Some project says they are infinitely scalable, and it seems to be better than just scalable, right?
Infinitely scalable sounds a lot better.
Yeah, but in fact, they achieve the same scalability in theory. It's just the one comes out from a more industrial project, and one comes out from a more specifically defined academic project. So, and then you see reports actually using their like propaganda term of their project. So they list them separately in the same report, which causes more confusing for the newcomers to understand it. So I think it's kind of natural because you can name your project, you can call whatever you want for your own advertisement, right?
Yeah.
There is no rule for that, but I think there is it does cause some issue, and there should be like more qualified reviewers on these terms.
Did you find yourself having to, like, when you're working with someone or working with another group that maybe you don't know very well, do you find yourself having to set that out from the start, like the definition, before you start working or discussing things like that? Or
in fact, there is. I think. Well, I've been through some conferences, and this is a very specific topic that has been only worked. Okay. So I think, for example, in this workshop, have you got to talk with the EPFL people?
Yes, I think there's a few of them, Lefteris and Philip.
Yeah.
Ewer.
Yeah. Yes. I kind of. Yeah. They one of them has a very strange name to me, at least.
Yeah. Yeah. Ewer Sitter. Ewer Stewer.
Okay,
Yeah.
I don't know, but I do know that two of the invited speakers are from EPFL. You have been talking with them, right?
I haven't talked with them yet.
Okay.
Well,
Yeah.
actually, I've talked with Philip and Lefteris before and over email, but I haven't spoken with them yet.
Okay.
I-
Yeah, but that doesn't matter. I think, for example, we wouldn't have a very uh, uh, difficult time in communicating in scalability because we will have the same base on the scalability, and then we know what we are talking about.
Yeah.
And basically, some other, like say, research groups I have been talking to. I have talking to Loy Lu from Singapore. He do you know, familiar with this name, Loy Lu? He is currently working on a project called Kyber Network, but
Oh, I've
he
heard of the
is
project. I haven't.
and he is from, I think, National University of Singapore, and he is also one of the few PhDs who actually did some research in blockchain for PhD, and he is the first people from academia who have a paper about sharding.
Hmm. Oh, well.
And yeah, and then I have talked to him with scalability problem, and it doesn't has any communication issues, and also have talked with Amin Gunsaira, and then there is also no communication issue. So in the academic area, I think scalability is easy to communicate.
Yeah.
Yeah.
But when do you think it will become more of a problem when business starts to get involved and when the kind of more real world applications start to emerge, more real world applications start to emerge, and investors and things like business, when you have to explain it to them, do you think problems will arise then?
Uh, yes, a little bit. Yeah.
Yeah, that's do you think, sorry, this is just slightly off question, just interested. Do you think enough kind of academics are working on blockchain at the moment? You mentioned that it's one of the few to be working on a blockchain PhD. Do you think there's enough?
Excuse me. Sorry, I have to say that I sometimes I couldn't understand your accent a little bit.
Oh, that's all right. Sorry, I'll try and speak clearly.
I'm really sorry. I haven't really speak to well, I'm here in Netherlands. It's not native speaking countries, and
Yeah, sure. Sorry, no, my voice is naturally quite deep as well, so it's difficult over the phone.
yeah, exactly.
But can you do you so do you think enough people are doing blockchain in academia? Do you think there are enough people
Yeah,
working on PhDs, or do you think there's a bit of a gap in the people that are sort of skilled in it?
well, I would say that the in the academia, I think people are slowly actually get involved into blockchain, and they because like they are like, well, in my opinion, like they are some professors, old professors might don't think blockchain is a new thing in the beginning,
Yeah,
and this situation is slowly changed. Like more and more people actually now start to believe that blockchain is actually a very interesting new problem, and it is a new area to explore and research. So there are more and more academia force getting involved in this blockchain thing. So there will be more PhD students who especially focus on blockchain, because you know that PhD students are the main like force of research.
yeah, definitely.
And but has that been said, and well, but they were kind of some pioneers actually believed in blockchain since Bitcoin,
Yeah,
and those people are basically the also the pioneer in this area, or in the academia area of blockchain. And well, well, I can name a few, like Amin Gunsaira from Cornell University.
yeah, he's a
Yeah, yeah, he is one of the professors who really getting known by the public.
Yeah, he's quite. Yeah, I think.
Yeah, and from and the professor from Edinburgh University.
Who's that?
Who has been I forgot the name, but who has been working on Ouroboros, which is picked by Cardano, and they actually started to research on blockchain and Bitcoin for quite a long time. And also like EPFL people and IBM research in Zurich, they have been started working on blockchain. Not as long as Bitcoin, but they have a very solid understanding on crypto and distributed systems.
Do you think that, like with something like, I mean, with machine learning and AI research, a lot of the like academics have been poached by big companies who kind of looking for the skill set that they offer. Do you think maybe before they've had a chance to complete enough proper research into the area, and people kind of have talked about AI research suffering because of that? Do you think something similar could happen to blockchain?
Okay, so let me repeat your question. You are asking that the big companies are like in. So sorry, I didn't quite get you. So
they're hiring people before, like PhD students, before they finish their PhDs or their masters, because they want the talent. They want to beat other companies to hiring that talent. Do you think that kind of problem could grow in blockchain? It doesn't matter if it.
Yeah, I think blockchain is still a relatively small area, and there is no such a big companies like Google or.
Yeah.
So there is kind of I don't think there is the situation is similar to the artificial intelligence.
Okay.
Yeah.
Anyway, yeah. So moving on to the questions. Go ahead. So, like, how big a problem is scalability for blockchain, based on your definition?
Well, I would say it's still a big problem. Yeah, but still, okay. So my definition of scalability is still like, yeah, that's that's okay. So that is still quite a difficult problem to answer. I mean, like scalability, there are two definitions, as I mentioned in the email.
Yeah. So if you kind of hang on. Oops, sorry, I just scroll down. So I mean, in terms of the solutions that solutions that you're working on.
Yeah.
Do you think that the problem that they're trying to solve, and other groups like Evan and EFPL, when their approach to scalability and solving scalability, do you think that they're successful? They're growing they're getting near to being successful?
I think they are quite successful. They have a very all-round approach on they proposed the Omni Ledger, which has a very all-round structure from how to define each step of the blockchain. They have and also the basic blockchain, and then they also define how they could do sharding and how they could do inter-shard transactions. So it's a kind of all-round scheme, and I think it's quite nice. So the scalability issue is, so what is scalability? In our point of view, it's all about the communication cost per transaction.
Yeah.
So the communication cost per transaction, if that is at the order of n, when the n is the number of the network. Mm-hmm. If it is at the order of n, then means that the transaction, the throughput will not grow and it will not decrease if the network size grows larger.
Okay. And
this is in most of the blockchain industry is believed to be already, they call it is a scalable solution.
Yeah.
Yeah, and then there are some groups like OmniLedger, then they propose sharding, and this is actually, I think, what currently the community wants is something we call scale out.
Yeah, yeah.
Means, yeah.
No, carry on. Sorry.
Yeah, means that the network throughput, the system throughput grows with the number of nodes in the network.
Okay, and is that a solution? Is that a problem that's nearer to being solved?
Yeah, there are many proposals like OmniLedger, and I will say my solution is also one of them.
Yes.
Yeah, and then I think there is, but these solutions are quite promising. I will say my solution as well, and they are
of course
promising,
the most promising
solutions. I can introduce my solutions a little bit later, but
yeah, no.
So the idea is that most of the idea is that we sacrifice a little bit of security or decentralization, and we achieve this scale out performance. And on my scheme, I will say that I sacrifice a little bit of functionality, and we achieve this scale out property. So then back to the question. So how big is the problem for scalability for the development of blockchain? I would say that we still want a very high throughput, right? Like talk about scalable solution. They are, I think, the two of the solutions which has the highest transaction per second. While in the laboratory setting is Algorand and Conflux at Tsinghua University recently, and they have a TPS of like thousands transactions per second for a network with thousands of nodes.
Okay.
And that then it's actually already quite good.
Yeah.
Right. So I think for so how big is the problem of scalability? Is scalability, then I would say for some blockchain, if they consider this throughput is already big enough, then the problem is solved by now.
Okay.
Yeah, and if they want really like the EOS claim that millions transactions per second, then it is an unsolved problem.
Yeah.
And I don't even know if that is achievable in practice.
Yeah.
In a short term, but what we want is scale out. So by doing something smart, we can actually get to like 10,000s of 100,000s per second.
Amazing. Can you tell us a bit about your kind of research and your solution? You know, I mean, you don't have to.
Yeah.
Go into too much if you don't want.
Okay, so then I will directly jump to a description of my solution.
Yes.
So this is a little bit old one because I have submitted a new paper, but since it's a double-blind process, I could not tell you too much about
I understand
that paper, but I have an old paper which have a similar idea. Like the idea is the following. So you have so if you consider like blockchain as a ledger or a database which has to be agreed by all nodes, then it has no way to scale out. It is limited to scalable because every transaction has to reach to all nodes. And this the performance, then you cannot really it will not grow as the network grows. So that's the definition of not scaling out.
Yeah.
And so all of these sharding or off-chain solutions, they try to increase the throughput by we let the transaction only be agreed, or let's say only be validated by part of the network instead of the whole network.
Okay.
Or, well, for off-chain, it's sometimes you said we believe that there are some trusted node who actually is authorized to validate all transactions. Or sharding is you divide the network and then you said a small part of the network can validate the transactions happens like within the shard.
Yeah.
So when there is a transaction cross the shards, then you need to have another approach to deal with that. But then the problem is becomes how can we divide the shards smartly so that there is not so much cross-shard transactions. Yeah. And also the cross-shard transactions is not very difficult to validate. So, but the key idea is still that we don't want a transaction to be validated by the whole network.
Yeah.
Yeah, and then my solution is kind of take a step back. So we are trying to look at what exactly is the problem we want to solve. So for Bitcoin, the ultimate problem that Bitcoin is solving is secure value transfer, right? Yeah. It's just how can we make transaction and how can we prevent double spending. That is basically the only thing that we want to achieve is to prevent double spending. And then the idea of how can we prevent double spending is that we need to have a globally agreed ledger so that everyone knows every transaction, so nobody can double spend. But then my solution is like, do we really need that everyone knows all the transactions to prevent double spending?
Yeah.
So, for example, if I receive money in real life, do I need to know all the transactions happen in the world to confirm that this value has not been double spent?
Yeah.
It's kind of also counterintuitive, right? So, so then I design a different structure, which everyone has their own chain of transactions, and then there exists the main chain. So it's kind of like a two-layer structure.
Yeah.
Yeah, but the idea is that it's not everyone only holds their own chain, but everyone actually in this structure holds a proof of their value is valid. And the proof actually includes, the proof is very simple. So as you can imagine, I received 10 euro or 10 pounds cash.
Yeah.
Yeah, and then how can I know that I have not, this money has not been double spent in my setting when everyone has their own chain of transactions? So basically, I will check into, for example, if you send me this 10 pounds, I checked into your chain and see you haven't double spent this money.
Yeah.
And then you receive this 10 pounds from another person. Then the proof actually includes his chain. Okay. And showing that he haven't double spent this money. So basically, then the proof saying that these 10 pounds haven't been double spent is not the whole transaction set, but only the transaction set, only the transactions, the chains of the one who once owned this 10 pounds.
Okay, like a blue book in a car.
Yeah.
Is that a good comparison? Not, or is that, am I looking at it from the wrong angle?
Yeah, but like for a blue book of a car, then you only register all the transactions with the car. But this actually requires that I also knows all the transactions of yours.
Okay, all right, both. Okay, so it's not just following It's not following. It's not following the just the £10. It's following your transactions too.
Yeah. Okay. So it's not only following the transaction record of this £10, but also basically the transaction records of all the owners of the £10.
Yeah. Okay. And then it's so that doesn't mean everyone has to agree in the world.
Yeah, that's still an improvement because then it's not the. So traditionally, you need the transaction record of everyone. Now you only need the transaction record of the previous owner of this £10.
Okay, that's interesting.
Yeah, and then there is a question. So how can I get the record of the previous owners?
Yeah.
Yeah, and then the idea is that we have already made these rational assumptions in all the previous blockchains. And this is not really specified, saying that basically as a rational transaction issuer, so if you want to send me £10, you actually want me to confirm it, right? So, for example, if I want to send €10 to my supermarket, I want to buy something from them, right? And then there is actually my obligation to prove that I have made this transaction to them. So then basically I'm motivated to give the proof as well as this, give the proof to them, as well as my money.
Okay.
And then the idea is like, so for every step of this £10, actually okay, so let's say it this way. So if you give me the £10, you will be willingly to hand over me your transaction record because you want to prove it to me.
Yeah.
Yeah, and same goes the previous owner of the £10. When he gives you the £10, he also gives you his transaction record. So basically, all you will have the you will have the proof naturally because you will have all the transaction record of the previous owners because this actually goes along with this £10.
Okay. Yeah.
So when you receive that, you have the proof saying this £10 is real, and then you add your transaction record to the proof and send it to me. Then I add mine and send it to the next person.
That's a really neat solution. So
it sounds quite natural to now, right?
It's like tidy and logical.
Yeah. Then the problem is actually how is this actually better than the traditional solution? This actually is a non-trivial part. So it sounds like okay. So a £10 actually if I want to validate a £10, then I don't need the whole transaction record of everyone. I only need the previous owners.
Yeah.
But the problem is I probably has a lot of money in my wallet. And so would that eventually end up with everyone still needs?
Yeah,
Yeah, so this is a non-trivial part, and this is something which I cannot prove. So there will definitely be some very weird situation that everyone still need all the transaction sets. So theoretically, I cannot prove that this one is better.
Yeah.
But there is something which is quite interesting, which I called spontaneously sharding in the previous paper. So if we use this kind of a scheme, it will end up with a consequence I call the spontaneous sharding.
Yeah.
So if I have two £10 note in my wallet, and one I received from here in the Netherlands, and one I received from you, right?
Yeah.
And then I want to make a £10 transaction to you. So which one will I use? I will definitely use the one that I received from you to send this £10 to you again.
Yeah. Oh yeah. Okay. Yeah, because all the transactions have already been.
Yeah. Exactly.
Confirmed,
because you already got the proofs.
Yeah.
So
and that's that's spontaneous sharding, that process.
Yeah, and then it will end up like the money will. So if everyone works, everyone like performs rationally, then every like 10 pounds nodes will tend to end up cycling in a small shard. And then it is kind of similar to the R chain. I'm not sure if you heard about it. R chain. It's another scheme proposed sharding. I think it's one proposed by one of the founders of Ethereum. But never mind. They propose something like there will be multiple shards in the network. Then every node decided what shards they want to participate in, and in my scheme, then every value, every 10 pounds will form a small shard.
Okay.
Because it's only cycle in these small shards, and then depending on how many values you have, then you will participate in some of the shards. And then I can prove that in some random graph model that eventually the number of shards you participate in and the union of that shards will also form a shard. And the size of the shard is actually smaller than the whole network. It's actually at a lower order of the whole network.
Okay.
Which means that it scales out.
Okay. Okay.
So, yeah.
So yours is similar to that in the sharding aspect.
Yeah. So there is no really. So that's why I call it spontaneous sharding, because we do not artificially divide it. It's just it will eventually form the shard itself.
Like a logical way for people to act.
Yeah.
Is to do that.
Yeah. And so what is the trade-off in here is that we made some assumptions like if I made the transaction, then I will show you the proof.
Yeah.
Which it's natural. Well, I still think it's very natural. And this is something that has already been used in the assumption of most blockchains.
Yeah.
But then for some other things, like if you want really a Turing complete blockchain, then some of the informations you cannot make this assumption. So what we sacrifice is the functionality. So this works fine for value transfer, which is the major functionality of blockchain.
Yeah.
But it doesn't work if this assumption doesn't hold, which I actually do not see many. I cannot come up with many situations actually.
Yeah, I think as an assumption, that's a fairly reliable, logical one to make. What people want from transactions is the trust.
Yeah, so there is only one, like there are a few things which I try to use my model on, but the thing it perhaps doesn't work. For example, if I consider each transaction as a rating, so like you give a rating for your Uber or you give a rating to a restaurant. So that is something that the rater actually do not have the motivation to provide to the guy who is being rated about the authenticity of this rating. And then also the guy actually, for a bad rating, he do not have the motivation of keeping that proof.
Oh, right. Oh, so he would get rid of everything that doesn't like abide by your high rating.
So that is what I said, which is against which is the exceptions of this model. So it only works for value transfer, but not for for all type of information.
But is there a way around that? How could you?
There could be a way around that.
Like have certain, I don't know, like with the rating, you could have the number of ratings next to it and the number that they've ignored. I don't know how that would work.
Yeah, there must be a way around that. We can build up a smart contract saying that then firstly you need to accept before you knowing what the rating is.
You must be because you must be able to motivate people to give reciprocal ratings. Otherwise, people now could, if your Uber rating got bad, you just delete Uber and re-upload it or something.
Yeah.
As a new person, so maybe there's Oh, that's interesting.
Yeah, but this is just an example saying that there is some limitation of my model, but yeah, so that's it. So
Yeah, but
mm,
there's ways around it, which I'm sure you will find very shortly. That's
yeah,
yeah.
yeah, that I already found, but
Yeah.
there's a.
Okay.
I think I can I kind of generalize it in the new paper, but then I wouldn't tell it.
Yeah, no. Yeah, no, I don't want to reveal anything
Yeah,
inadvertently.
that's the review process will end by the time of the workshop. So I probably will say more about that on the workshop, but I don't know.
Oh, excellent. Looking forward to hearing it. Um, yeah, I mean, I think we've kind of touched on everything really. Like
Uh,
other question wise, it's like
yeah. So
sharding.
if you still want to ask questions, then it's fine. Although that I already covered some
Yeah,
of
I
them.
think you've kind of covered that. You've covered sharding and off chain, and
Yeah.
um, yeah. I mean, who are you kind of particularly looking forward to hearing at the event? And
Yeah, I will definitely want to meet up with all the keynotes, all the speakers, because I see that they all have all have some papers about blockchains. Because I see a lot of conferences, even like a lot of blockchain conference, even serious
mm,
research conference. They build up a new workshop for blockchain.
yeah,
But if you see all the speakers, they are from other areas. They probably are good researchers in that area, but they have not done any research about blockchain
oh
before.
right,
Yeah,
right,
so they are the people who want to get involved in this new area, right? But this workshop, which attracts me the most, is that I see that all the speakers, some of them I know their papers,
yeah,
some of them I see they have papers with some authors that I also know. So I think they are good researchers and they have already been in this area. So I'm looking forward to have a conversation, have a discussion with them about blockchain.
oh excellent. Yeah, no, I'm really looking forward to the workshop. So it's 5 weeks now. Well, yeah, thank you very much for your time.
You're welcome.
And I'll get that written up, and then I'll send it over to you, and you can take a look, and
Yeah,
like
please.
anything you want taken out, or if there's something I've misunderstood,
Yeah,
yeah, you can take a look. But yeah, I'm looking forward to meeting you at the conference and hopefully hearing more about your latest research.
sure. You will be there in the conference, right?
Yes, I will be coming over to Amsterdam.
Oh, great.
I'm looking forward to. Haven't been to Amsterdam for a while, so I'm looking forward to it.
Yeah, me too.
Yes, should be fun. All right, thank you very much for your time.
You're welcome.
Bye
Thanks
bye.
for the interview.
Yes, brilliant. Bye
Yeah, bye. Nice day.
bye. You too. Have a nice day.